Kayla. All right, ladies and gentlemen, it's math class time. It's Wednesday, April 21st. And for those of you that are home, we all say, hey.
Hi.
All right, we're going to start in our composition books. We're going to spend today and tomorrow on angle relationships. This is a revisit because we've already talked about this, so it should be fairly simple. We're going to put some vocab in here. First vocabulary word, adjacent angles. Adjacent means next to. Okay? So it looks like this. Adjacent angles are two angles that sit next to each other. They have a common side. So this side is part of this angle, and this side is part of this angle. They also have the same point or vertex. So the point down here is called the vertex. And they share one side. That's what makes it adjacent. We've already talked about these, but let's write this down. Complementary angles are two angles that add up to 90 degrees. Complementary. So if you check this out, we know that's a 90-degree angle. So this angle and this angle together would equal 90 degrees. So adjacent means next to, complementary means add up to 90. Supplementary two angles that add up to 180 degrees. And remember, 180-degree angle is a straight line. Yes. Sorry. So supplementary angles would be like this angle plus this angle next to it. If you add them together, it's 180 degrees. And you know the 90 degrees is because the square is there. And when you're done with that, I'm going to have to turn the page. If you guys still have space, that's good. I'm going to add like a couple more things. Yep. Okay. Congruent shapes. Have the same size and the same shape. So it would be like same size, same shape is congruent. And then I think yesterday we talked about similar shapes, right? So that's a little bit different. They have the same proportions. But they would be like this. They're not the same sizes. I think the example they used was, so this is kind of double. It's the same shape, but it's not the same size. Properties of triangles. They have three sides. They have three angles. And the angles add up to, who remembers? 180. And then this is another thing we already talked about, so I'm not going to spend a lot of time on it, and I just have a little space left anyway. We talked about angles that are created when a line intersects parallel lines. Remember when we talked about that? Opposite angles are the same. Remember we did that? So I put A's matching up in each of those corners where those are all equal. And then I'll put X's on the other ones, so you know all of those are equal to each other. These are actually called vertical angles. So it's just kind of a short review of things that we've done and talked about before. Just one last practice before we get to the M step. So once you're finished with that, you can close that. Yes.
What's that other word? Vertical what?
Vertical angles.
Can you go to the other?
I can.
You make a triangle. Maybe you push too hard.
When you close your composition books, we're going to take a look. We have 8 practice problems we're going to do together. When we're done with this, we're done for the day. We're going to kind of, like I said, split this lesson into 2 parts. If you need my notes, they're right here if you want to grab them later. Okay. So let's see what you guys remember about this. It says, look at the triangles below and classify them by side or side measure. So what do we know about where every single side has the same number of hash marks? What does it mean?
There's 3.
What does it mean about the sides? They're all equal, and so this is called an equilateral triangle. What do you notice in this picture about this triangle? There's a code. It's got a right angle. This is called a right triangle. Triangle C. Here's my clue right here. That angle is 109 degrees. What kind of angle is it when it's more than 90?
Obtuse.
An obtuse triangle. You guys remember more of this than I thought. Last one. 2 sides are matching. 2 angles are matching. Isosceles. I never remember how to spell this one.
Oh, I think I do it. O-S-O-S-C-L-E. Yeah, there's a C somewhere.
Yeah, I put it there. I don't know.
That's how I isosceles.
Yep. Feeling okay about that one? That was pretty easy. Let's take a look at number 2. All right. We are going to look at, okay. So read each statement, determine whether the statement would result in a unique triangle. I have no idea what they mean by that, so we'll just dig in and see what we can figure out. No triangle, or more than one type of triangle. So in these two, it gives us the degrees of all three angles. So for both of those, how would we check to see if that's going to be a triangle?
You add them up.
Add them up and see if it equals 180. If it does, we're good. If it doesn't, we're not. 45 plus 65 plus 90. That is not a triangle.
No triangle.
Let's check this second one. So,
Wouldn't the first one be more than a triangle?
huh?
You said the first one wouldn't it be more than a triangle? More.
No, it says more than one triangle.
Oh, it has to be 180. Wait, why did you check?
Because these two are going to solve the same way by just adding up the degrees.
Oh, yeah.
Because that to me is the easiest one to answer. Emily.
I was going to say no triangle would be like no triangle, but more than one would be more than one triangle. But a unique triangle, I think it would only be one because it's unique and it's one.
Yep.
One thing.
Yep, so we're going to try it and see what we got. So if all three of these angles add up to 180, we know it is a triangle. Let's look at what else we know. Every single angle is less than 90 degrees. So what is it when you have all acute angles? Acute triangle. That's the unique one, I think.
I remember because if it's small, it's a cute triangle.
It's a cute little triangle. Okay, an isosceles triangle that has two angles that measure 20 degrees. So let's do an isosceles. Let's see, how do I do that? 20 and 20 would be 40.
No triangle.
So what does the third angle have to be? It has to be 140. So can we draw a triangle like that? Let me think.
Sure.
Let's do this because it's got to be more than 90, right? So this could be 140. And then both of these would be 20s. That would work, wouldn't it? So it's actually counts as more than one kind of triangle. So here's where we get the more than one. First of all, it's an isosceles. And, Josh, obtuse also because this right here is greater than 90. Yes, Rayanne?
What if the one with the greatest size and a cute triangle, what if that also be scaling? Scaling
Which one?
all different lengths. The one that's a cute triangle. Yeah. Wouldn't that also be scaling? Yeah.
Oh, you know what? It could be. All different lengths. Yep. Good catch.
You're so smart.
A side length of 5 and 6 and 13. All three sides are different. What do we call those? Yep.
Yeah. Oh, we're writing scaling.
Because it can't be a triangle. The top.
I thought you.
The side lengths 8, 9, and 17. Scalene again. What do you think? So far, so good?
Sure.
Sure.
You might as well say sure.
Okay, number 3.
Oh, poor Mr. Brock.
Mr. Brock drops a stack of cards that match the triangle to the correct equation. Determine which equation can be used to find the missing value, then figure out what is x. Mackenzie,
I think that A goes to 4
why do you think so?
because it's 3x and there's 3 Oh.
And so if I go 3x to, let me finish up. So if I go down here and I go 3x equals 180 and I solve for x, I have to divide by 3 on both sides. All the angles have to be the same amount. So x equals 60, and we think this is A. Good call, Mackenzie.
I noticed it because it's like the only one it says 3x. You can only have it's like all the sides.
Exactly right. Exactly right. All right, tell me another one. Tell me another one. And how do we know that? Who said that first?
Cody.
All right, Cody, how do you know?
Because it's 2x.
We know there's a 110,
Yeah, there's
And 2x.
and the other two angles are exactly the same number. It adds up to 180. So what's left if I subtract 180 minus 110,
70 divided by 2.
divide by 2,
35.
and no other problem.
and there's letter B. Wyatt.
C is 1
And how do you know that?
because it says x plus 110. So you have the x in the top corner, and then that square means 90. 90 plus 20 is 110.
X equals 2.
So x would equal. Ooh, I don't know.
So 90 plus 20 this is 110
Yep.
plus this x. So what is this number going to be?
170. I mean,
70. X equals 70.
That's gonna get you.
That's letter C.
Oh, I know.
Shh, just a second. Aaron.
D is 2. Yeah.
D is 2. How did you decide that?
Because it's 2x and 3x. If you add them, it's 5x.
Oh, good job. 2x plus 3x equals 5x and 35. So right there, this is letter D. And x equals what? So let's figure out how we would do this. We're going to take 180, subtract the 35, and I have 5x equals 145. We got to divide both sides by 5. Let's see, it'd be 29. Rayanne.
I'm confused about the one that's like 1 and C. How was that?
Okay, who picked that one out? Okay, Wyatt, explain to this.
So, 1 and C, it says x plus 110. You have the x in the top left corner of the triangle, and then the square means a 90-degree angle, and 90 plus 20 equals 110. So the x plus 110 equals 8.
Oh,
180, and then the x is 7.
That's the new reborn.
I didn't even think about
Just a second.
Oh, okay. So I thought it was 110 plus 70 and plus 20. I was like, that doesn't add up.
Yep, it's the 90 plus the 20 that got us there. Well, that means number 5 has to be what?
B.
Let's see. Good heavens.
Jeez.
I just say this, process of elimination.
Yeah.
You think?
Moving on to station 4.
Moving right along. I like that. Read each statement below. Use the diagram to describe the relationship. So let's get started. C, B, D, and D, B, E. Angle relationship. They are adjacent, right?
because they're right next to each other.
They're right next to each other. Two angles with a common side that are next to each other.
So we have notes.
Now we got, I'm going to pick a different color. See if I have enough colors. Okay. DBE and EBF,
Adjacent.
adjacent, and what else? Mm-mm.
Right.
They add up to 90 degrees. What's that called?
Right angle.
A right triangle.
The two together add up to a right
Oh,
We just put it in our notes. Complementary.
Here's it's complementary.
I already said.
Okay, I've got red. A, B, E, and
CBD.
C, B, D. All right, that one's a little crazy. So
it's cute.
I know.
How did you get CBD? Isn't it EDF? CBD is a
Yeah.
A, B, E. Oh, okay. A, B, E, and E, B, F. Oh, okay, that makes more sense.
Yeah.
No, they are adjacent
How?
because they're next to each other. You're right. They share a common side. They're also add up to what? Which is called?
Supplement.
Supplementary.
Okay, did we miss anything? All right, A, B, C, and C, B, D.
Probably all of it.
So this one, and this one. It's adjacent and
Right.
no, they add up to 90.
Complementary.
There you go.
Adjacent.
Adjacent angles, you put them in your book. Let me show you.
It's. Oh, there's no definition.
Adjacent angles. They share a common side. This line is part of this angle and part of this angle. So they're next to each other and they have the same vertex.
Middle.
All right, last one. A, B, C, and C, B, F. Adjacent and
Supplementary. Same thing.
Gee, just saying random.
What do you have with one about the last one?
They're all adjacent.
They're all adjacent.
They're all.
Really, Josh?
Well,
Jason's very popular.
Station 5. Station 5. Let's keep going, guys. Solve each problem below for the missing angle measurement. You have to find the missing angle, and then you have to draw it.
Oh.
An isosceles triangle. One angle is 20 degrees more than twice the one of, oh my word.
This is called a one.
You ready? All right, let's take it apart. We know what it means to be isosceles, so that's good. You guys ready? One of the angles is 20 degrees more than twice the measure of the one side of the equal angles.
It's so hard.
We don't know where the equal
Hang on, guys. Listen. Go, Emily. You had your hand up.
Yeah, I was gonna.
That's what I'm waiting for.
Okay, so
Let's see what Emily
I
thinks.
was looking at it and it says it's 20 more than twice the measure of one of the equal angles. So what I was thinking was I can't explain it. I don't know. I was thinking 180 and then it could be yeah, that's basically what I was thinking. I just couldn't say.
So all we're doing is we're doing the same thing we did on that page where we had to match them, but we have to actually come up with the equations this time. So we know that one of them is 20 degrees. That's right?
No.
It's
20
20
more
degrees
than
more.
2 times.
More than 2 times A. But where are my 3 angles?
One of them's 20.
And then you have to do
So watch what we're going to do. Let's see what we're going to do. We're going to subtract 20 from both sides because we know how to do that.
I did divide it by
Oh, this is a 2 set.
Yeah, because don't you do multiplication?
Divide.
It'd be 60.
That's what I meant, Josh.
80 for 2.
So let's see if that makes sense. The three angles, guys, two of them are going to be 80. So it would be 80 plus 80 plus 20.
Oh,
That's 180.
Oh, look at that. We figured it out.
I thought it was.
Wait a second, let me have this here so I can.
wait. Where do we write
I don't know.
Can you not?
80, 80, 20.
Shh. We don't have space to draw, so we're just going to do this. We're good.
Really?
Okay.
You need a diagram.
Okay.
Be sure to draw.
Be sure to draw a diagram.
Not me.
I do remember.
Everybody.
Be sure. So equilateral triangle, isosceles, these would both be the same. There's my 20. And then both of these would be 80. Please, it's math.
I'm coughing.
I know. I was coughing too. Right, Emma?
Yes.
Emma knows what I'm talking about.
What?
Nothing. You wouldn't understand.
Yeah, I don't understand.
In triangle DEF, here we go. Triangle DEF, the measure of D is 122. So there's 122. E has to be acute, which means it's less than 90. And F is 19. So how do I find out what E equals to? Mackenzie.
Isn't it 122 minus 19?
Well, the total has to be 180 to be a triangle, right?
Plus, add.
Guys, listen.
That's what
We're getting back into that. Everybody yelling out. Cody, what would you suggest?
Add 122 and 19 together, and then subtract the total from 180.
All right. So
Oh my
let's
goodness.
check it out.
I thought 122 plus 19 equals.
You could do it this way. Take 180, subtract 122, subtract 19. This one has to be 39.
30.
20. 21.
Adjacent.
Jason.
Two angles are supplementary. What does that tell us?
Add up to 180.
So it has to create a straight angle. So here's my 180. The first angle is 38.8 degrees. What's the second one going to be? How do I find out? Cody.
What you take 180 minus 38.8 and then divide the answer by 2?
No, because this plus this equals 180.
You already got the
You don't have to divide by 2.
I was thinking
Station 6. 6, 7, 8. We are going to be out of time on our video, so here's what we're going to do. I told you that we're going to split this lesson into 2 parts, so we're going to stop right here. All right, so let's put